Good morning everyone. My name is Sai Krishna. So today our topic is about compatibility and configuration testing. Let's see what it is. So first we are going to discuss about compatibility testing. So here in this type of testing we actually test the application by running it on different operating systems. Like if you take the mobile phone, the operating systems are like Android and iOS. So we run that application on different operating systems to test the compatibility of that particular application. So it is actually a non-functional testing where we test the usability and reliability and performance of a particular application in different computing environments, that is operating systems. So for instance, if we take a mobile application, we test it on Android and iOS to verify its response on both the operating systems in the same way. Okay. And the different types of software compatibility testings are below. The first one is browser compatibility testing and hardware. The next one is networks, mobile devices, operating system, and versions. These are different types of software compatibility testings we can perform on particular application. So in the hardware, we usually check the application compatibility with different hardware configurations. Like if we take a particular hardware, we install the software and we test the compatibility with that particular hardware of the hardware with the application. And in the network testing, we test the application with different types of networks like 3G, 4G, 5G, etc. And as I said before, we test the like it is one of the example. We test the application in different operating platforms like iOS operating systems like iOS, Android, and Windows, etc. in mobile devices. And coming to operating systems in systems, we can check them on Windows, Linux, and Mac, etc. And the last one is about versions. It is to test the software application in different versions of the software. Like we know, if we consider WhatsApp, we will have different releases. Like we will have different versions. So we will test the different versions of the software here. The next. Okay. In configuration testing, here this is about the test the software application with variety of software and hardware combinations. Like we all know money counting machines, like it is a hardware device and it will have an application to count the money. So it is actually the combination of hardware and software. So here in configuration testing, we test the software with the different combinations, like different software and hardware combinations. For example, a software application connected to the hardware like money counting machine. So here this combination will be tested in the configuration testing. And there are two types of configuration testings. There are software testing, software configuration testing, and hardware configuration testing. So in software configuration testing, the testing can be done with multiple operating system versions and various browser versions. So like if you take an operating systems like Windows, and and the browsers like uh, Google Chrome, etc., we will test that combination here. And software configuration testing is very time consuming process because we have to install and uninstall them while testing here. And so hardware configuration testing next. In hardware configuration testing, here the physical machines were tested with various connections, and it can be done only in labs. Whenever a new build is released, the software has to be installed in all physical machines where the hardware is attached. And here we have to run each machine to ensure the application is working without any flaws and errors. This is all about compatibility and configuration testing. Thank you.
Myself Ramesh Kumar Aksetti. Now we are discussing about one of the important topic in testing department. It is the root cause analysis. The root cause analysis means identify and eliminate the root cause of the defect. We have defects occur during the production or during the testing. It is a main root cause is there for the particular defect. We need to find the defect, find the root cause, and eliminate the root cause. We can understand this concept by simply seeing this diagram. These are the symptoms is nothing but the defects. We are defects coming to the different servers. The causes are nothing but the reasons for the defects. We need to find the different causes and we need to find the root cause of the particular problem. We need to eliminate the root cause. By that way, we can prevent the defect and we make the defect doesn't remove and reproduce it furtherly. This we can relate this topic to our testing department. We have a production defect. We can deploy the application to production server after completion of testing. So one defect is coming in production server, for example. There are several reasons for the defect. For example, we can see the reason in different departments. For example, testing department is the reason for the defect. How to find the root cause in testing department mistakes? Now we see that topic. For example, a defect occur in production server, but that defect passed in the testing server. We need to, whenever client told to us we have a defect in the production server, we need to, first thing we need to check that defect in the testing server, whether the defect is passed in testing server or not. For example, we didn't test the defect in our testing server, because the reason is we have several reasons for that. We didn't write the test case for the particular point, and reviewer doesn't review properly that particular point. In some cases we test the particular point, but we test in different way. For example, we didn't use test data properly. In that case, password have contained two capital letters, but we test only one capital letter. Due to that reason, it has chance to occur defect in production server. In the testing department way, when it comes to development, developer doesn't write the code for the particular point what defect occur in production server. If developer develop the point, okay, but you didn't write the code well, it is a code error. It has a chance to occur the defect due to that reason also. And we test the application in quality server, the point will be passed, and developer also develop the point correctly, they write the correct code, but we have defect in the production server. Now in this case we need to think from out of the box. Due to the installation process, when we install the application from our quality server to production server, there is a chance to mismatch some files. Due to that reason also we have production defect. This is one of the reason. In this case we think the three different departments, and we think about the many reasons, and we need to find out the ultimate cause for the defect, and we need to find eliminate. For example, production server defect occur, we test well, but development code error is there, for example. So ultimate the root cause is the, we need to give explanation to the client. The code error is there in the coding level, we need to fix the change, and we need to remove the patch again. So that is the root cause and that particular problem. It is all about the root cause analysis. You have another two topics, defect leakage and defect rejection. Defect leakage is nothing but escaping the defect from the one level to level to next test level. It is called a defect leakage. Defect leakage is the metric that is used to identify the efficacy of the QA testing. It is calculated by using a formula, number of defects found in production or UAT by number of defects found in testing. We test quality server first of all, and we have some defects, and we didn't find some defects in quality server. That defects we find in UAT testing. So here mean quality production testing server 2, we find 30 defects in testing server, and we find 10 defects in UAT server, and we find 10 defects in production server. Production server defects find by user, then users are the clients. We find 3 defects. So we need to find 43 defects in testing server. Actual goal is our goal, but we 10 defects leakage from the UAT server from testing server 2, and 3 defects leakage from the production server. It is the defect leakage. The QA team is responsible for defect leakage. We need to give the explanation, and different reasons for this defect leakage is lack of test cases to cover satisfactory conditions, absence of specific test cases, and review process. We write the test cases correctly, but they didn't review processes correctly. So we didn't cover the test cases. It is one of the reasons for defect leakage. And environment differences. We discussed about during installation, maybe some files are not transferred correctly. Due to that reason also we have defects. And incorrect deployment in UAT or production. And because of unclear requirements or poorly designed test cases. We didn't have complete requirements, or we didn't understand the requirements well. In that case also, it is a chance to defect leakage. And use of incorrect test data, and occurs due to not performing regression testing. For example, we have a defect and the developer fixed the defect, and we didn't perform the regression testing. Why we perform regression testing? Because due to the code change, there is some impact in other functionalities too. That's why we perform regression testing. In case we didn't perform regression testing due to changing some, for example, in create user table, there is a functionality is not working properly, that's edit user. We assign the defect to the developer and he fix the code for and he correct the edit table. Due to this code change, some cancel button not working properly. It is the reason for defect leakage. So if you test cancel button too, we can prevent the defect leakage. If you didn't go with the regression testing, it has a chance to damage other functionalities. That is one of the reason for defect. The defect rejection. The defect rejection is should be not if the raised defect should not impact any functionality in application, then the developer reject the defect. During the testing phase, we can find some defect and we raise the defects in the ALM or Jira, and defect is not valid because they didn't obey the defect to show any impact on functionality. They reject the defect. We can find the defect rejection ratio by using a formula called number of defects rejected by dev team by total number of defects into 100. Next slide. And the reason for the defect rejection is misunderstanding the requirements. If we didn't understand the requirements well, we don't prepare good test case documents. It is one of the reason. And requirement implementation. We understand the requirements well, but we fail to implement it. No clear requirements. There is no clear requirements from the end users. And change in requirements. In agile model, they can capable to change the requirements in middle of the project, but we didn't know they are changing the requirements. We follow to the previous test cases, but they are changing the requirements. This is one of the reason for defect rejection. And test data used and improper test case design.